Okay, let's look at number 29. It says the distance from the restaurant to the shoe store is the same. Let me get this up here. The distance from the restaurant to the shoe store is the same as the distance from the cafe to the florist. All right. And the distance from the shoe store to the movie theater is the same as the distance from the movie theater to the cafe, and from the florist to the dry cleaners. Okay, so that's a lot to remember and a lot to get in our brain. So it would be good to illustrate this. This isn't a problem that's a good example of uh, illustrating what's being given in a problem so that we could come up with a plan. So let's try to make an illustration of this so that we can see more clearly what's going on. So we've got a line of stores, okay, and the first one is the restaurant. Okay, so we've got a restaurant, and the distance from the restaurant to the shoe store. Let's say this is the shoe store. Hopefully I don't run out of room. So we've got the shoe store. The distance from the restaurant to the shoe store is the same as the distance from the cafe to the florist. Let's go ahead and put the movie theater in here. They're helping us out with this illustration here. We've got the movie theater. We have the cafe. We have the florist. So I'm just going to put points here on this line and label them with the first letter of each store name. And then we have the dry cleaners. Okay, so we're being told that the restaurant, for the distance from the restaurant to the shoe store, I'm going to put a congruent mark here, is the same as the distance from the cafe to the florist. So these two distances are equal. So these segments representing these, from door to door are congruent. And then we're told the distance from the shoe store to the movie theater, distance from the shoe store to the movie theater, I'm going to put two congruent marks, we're talking about different values now here, is the same as the distance from the movie theater to the cafe. All right, and from the florist to the dry cleaners. Okay, and so use the steps below to prove that the distance from the restaurant to the movie theater is the same as the distance from the cafe to the dry cleaners. All right, so let's write what's given, and let's write what we want to prove so that we can start coming up with a plan. So it's given that RS is equal to CF, and that SM is equal to MC, which is equal to FD. All right, and we want to prove that the distance from the restaurant to the theater is the same as the distance, so from the restaurant to the movie theater, that's RM. We want to prove that RM is equal to the same distance as from the cafe to the dry cleaners. So we want to say that it's equal to CD. Okay? So we want to prove that RM, let's go ahead and put S, M, we want to prove that RM is equal to CD. All right, we want to prove that RM is equal to CD. All Alright, let's get rid of this. I don't think we need to do this part here. So we want to prove that RM is congruent to CD. Alright, so if we look at it, that's pretty easy to see. Well, maybe not easy, but we can see that, alright, that they are, okay? You know, let's just say that RS was 1 unit long and SM was 2 units long. So that means CF is 1 unit long and FD is 2 units long. Okay? So we can see that RM is equal to CD. Alright, the problem is how we're going to spell that out in a proof. Okay? And so I think the best thing to do would just be start with what's given and just do some manipulation and go from there. We could see that alright, so let's start with the fact, you know, what's given. RS is equal to CF and SM is equal to MC and FD. That's given. Okay? And then let's state that RM is equal to RS plus SM. Okay? A segment addition postulate justifies that. And then the same thing with CD. CD is equal to CF plus FD. Alright, so I'm just stating what I know and what's easy to see, and then see what I can do to maybe manipulate these so that I can get that RM is equal to CD. And I can do a little substitution. I'm going to substitute with RM. Okay, if I look at RM equal to RS plus SM, notice that RS is also equal to CF. So I can substitute CF with RS, and notice that SM is equal to FD. Okay, SM is equal to FD. So I'm going to substitute RS with CF, that's what I have here, and I'm going to substitute FD with SM, and that's what I have here. So I get this, when I do some substitution, I get RM is equal to CF plus FD. Okay, so I have RM is equal to CF plus FD, and I have CD is equal to CF plus CD. And then I can use the transitive property to say that RM is equal to CD. Notice that I have in these two statements, in step 3 and in step 4, notice I have like quantities. So this is kind of like saying if A is equal to B and B is equal to C, then A is equal to C. CD is equal to RM, or RM is equal to CD. So we have proven, we've spelled out why, what we saw at the beginning, why RM is equal to CD in length. So I hope that helps a little bit. You should have tried it yourself before you looked at this.